All right, this is starting off chapter 6. We are in chapter 6 is called Operations on Rational Numbers. And if we were in class, I would say to you, what's a rational number? And you would tell me it's a fraction that will either divide to give me a repeating decimal or a terminating decimal or no decimal at all. They can be both positive and negative. So we're going to look at going through the examples one by one. We're going to do the example and then an additional problem using that same concept. At the end of this video, I will tell you what your expectations are for your homework, and then you can do that, take a picture of it, and email it back to me. And it will be due tomorrow. Today is Monday, December 6th. Homework is due tomorrow, which would be Tuesday, 12/7, by midnight. Okay, we'll just set the homework on its due date. Just make sure that you get it in by midnight the next day. That will be for only this week when we're doing video learning. Okay, let's move on. 6.1 is addition and subtraction of rational numbers. Now, rational numbers are fractions, so you know that when you add and subtract fractions, the one thing that you need to look for is a common denominator. In example 1, we have 4/9 plus 7/9. And if I notice, so this is the stupidest question you'll be asked on a Monday morning, is my denominator the same on both? Well, both of them are 9s, so they are like, so I have no requirements as far as changing the denominator, so both the numbers are one number if they're different. So when I add rational numbers, I keep my denominator always and add the numerators. So 7 and 4 is 11. Okay, that's example 1A. B is 11/12 minus 3/12. And to evaluate that rational difference there, difference being subtraction, I notice that my denominator is the same. I carry it over and keep it and subtract in the numerators. 11 minus 3 is 8. We will also have some other types of problems where, and if they're top heavy, leave them that way. Don't put them back to mixed fractions because that just makes this more difficult than it needs to be. So if you have a mixed fraction, make it an improper. Okay, so an additional problem, I might have 13/6 minus, say, 7/6. I notice that my denominator is common, so I carry it over. 13 minus 7 is 6. Well, this is where we're going to talk about reducing your answer. If your answer is something that can be reduced, you will do that. 6 divided by 6 is 1. Say likewise, I get 13 over, let's say, 20. And I'm going to keep my denominator common. And let's look at let's say 27. Okay. Notice that they are top heavy. Doesn't matter. Leave them like that. Your denominators are common. Carry it over. 13 and 27 is 40. So again, with this fraction being a reducible fraction, 40 divided by 20 is 20. Now, if it's a fraction that, say you get a fraction answer like 6/9, do not give me the decimal equivalency of that. What you'll do is you'll leave it as a fraction, but you'll just reduce it. So 3 goes into both 6 and 9 evenly. 6 divided by 3 is 2, and 3 divided into 9 is 3. So no decimals, just reduce your fractions to the lowest terms, or if the numbers divide to some answer like 1 or 20, where you've got no decimals at all, definitely do that. Okay, so now the next thing we're going to do is example 2. With a couple of additional problems. Okay, so example 2, we're finding a denominator when the two denominators that we have are not common. Okay, so in example 2, we have 5/8, and we are adding to it 2/3. Now, there's a couple of different ways that you can do this. In fact, there's 2 ways that you can do this. I'm going to show you both ways just for the sake of some minds might comprehend one method better than the other. So if I start with the multiples method, start with the highest number, which is 8, and I'm going to take multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32, 8 times 5 is 40, etc. Now, what I'm going to do with those multiples is find the least multiple of 8, or the lowest multiple of 8, that 3 will also go into. Does 8 divide by 3 evenly? No, it doesn't. Does 16 divide by 3 evenly? No, it doesn't. So it's not, the common denominator is not going to be 8, and it's also not going to be 16. Does 3 go into 24 evenly? It does. So my denominator, my least common multiple of 8, that both 8 and 3 go into, will now serve as my common denominator. So I'm going to write that down here. My common denominator is 24. And if I know that I have to multiply 8 by 3 to get to 24, I'm also going to multiply 5 by 3 to get to the equivalent fraction of 5/8. In other words, if I reduce 15/24, what it'll give me back in its lowest terms is 5/8. Same thing with the 2/3. If I have to multiply 3 by 8 to get to 24, I'm also going to multiply 2 by 8 to get to 16. And one thing I'm going to say here, and this is going to prove whether or not you actually watched this video, is for you to understand that I know that your calculator can do this for you. I know that your calculator can find a common denominator. I get that. What you're going to show me to let me know you understand this and that you're not using your calculator, you're going to show me this work right here. What you're multiplying in to get to that common denominator. You will show me that work that tells me what you're doing to find your common denominator. Okay? That work will show me that you are actually working through the problems, finding the common denominator on your own, as opposed to letting the calculator do it for you. Okay? So from there, all we would have to do, now that our denominator is common, we're going to carry it over, and we will add 15 to 16 to get, because it would be just like me to be putting numbers in there wrong. 31/24. Yes, it's improper. Leave it as an improper fraction. Is it reducible? No. 31 is prime, so 31/24 is how you would leave your answer. The example has the mixed fraction. The only time I want the mixed fraction as the answer is if the instructions for the homework section tell you to leave it to express your answer in a mixed fraction. Other than that, I want it to be a, just leave it as an improper if it is, but reduce it if you can, okay? Another set of instructions may tell you, give the answer to the nearest hundredth. That means that you will give me the decimal. But if the instructions don't tell you how to express your answer, I want it to be left as an improper fraction, okay? So the other method that we could use, and I'm going to do that over here, The other method that we can use, which is a simpler method, would be just to look at your two denominators. They are 8 and 3, and just multiply them together. Okay? So that's the other method that we would do if you don't understand using the multiples of the larger. Okay? So we'll do an additional problem over here. Okay? Denominators, let's say 3 over 7 plus, I'm just pulling numbers, say 5 over 9. Now, obviously, the stupidest question you'll be asked on a Monday morning is 7 the same as 9? To which you will, of course, answer no. So that means that we need to find a common denominator. Now, I'm going to start with the larger number and take the multiples. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9, sorry guys, 9 times 6, 9 times 7. Well, I know I don't have to go up any farther than that, because 9 times 7 would be the greatest common denominator if I don't find another number that 7 goes into. Well, we know that 9 doesn't go into 7 evenly, or 18 or 27, any of them. The common denominator is going to be 63. So this problem illustrates how to use the multiple method, the multiples method, and multiplying 9 times 7 together to get 63. Because if I go through all of these multiples one by one and I try to divide 7 into each one of them, it doesn't go in evenly. The first time I find an even division is when I have a 63. And 9 times 7 is 63. So that's how you use the multiple method. And an example of how you also just multiply your denominators together. 63 is your common denominator. So I will carry that over regardless of what goes in the numerators here. From 7 to 63, I multiply 9. So I have to multiply 9 by 3. 9 times 3 is 27. In my second fraction, 5 over 9, I have to multiply by 7. So I multiply the 5 by 7. 7 times 5 is 35. And then what I do after I've carried over my common denominator is add together the numerators to get 62. Now, it would lastly be up to me to determine if 62 over 63 is reducible. Okay? It's not, so that's my answer, and I will leave it like that. All right, example 3. We are subtracting with uncommon denominators. So example 3 and an additional problem will be over here. Okay, so we'll do from example 3 in the book. We have 7 over 10 minus 4 over 15. So again, I notice my denominators are not common. I'm going to start with the larger of the two numbers and find the multiples. 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. And let's do one more. 15 times 5 is 75. Okay? Well, you know, with the nature of 10 being what it is, it ends in a 0. So it's only going to go into another number that ends in a 0. It's not going to go evenly into 15, 45, or 75. Okay? So if I look at what's remaining, I need to see if 30 is divisible by 10. Well, it is. Now, 60 is as well, but we pick the least common as our common denominator. So 30 is the least common multiple of both 10 and 15, so that is what is going to serve as my as my common denominator. So I will use my 30 as my common denominator, and I'll carry it over because that's what we do. And in order to get from 10 to 30, I multiply by 3. So I multiply 7 by 3. 7 times 3 is 21. In order to get from 15 to 30, I multiply by 2. So I have to multiply 2 by 4 to get to 8. And then, since I've already carried over my common denominator, 21 minus 8 is 13. And 13 is prime, so it cannot reduce when it's in a fraction with 13 over 30. So an additional problem, let's look at 8 over 13 minus 4 over, let's say 10. That's probably going to be a big one. 13. You know what? Let's do an easier one, because I think there are so many multiples of 13 that we would have to go through, that we probably would have an easier time if we had a number that was a little bit nicer. So let's look at 8 over 15 minus 3 over 5. Okay, so 3 over 5. Common denominator is what we need here, and we're subtracting. So this is what we'll have. We'll have a common denominator down at the bottom, minus, and then our numerators will reflect that multiple. So I take the larger number, and I start with the multiples. 15 times 1, 15 times 2, 15 times 3, 15 times 4, etc. Okay? Now I'm going to see which number 5 goes into first, and that'll be my common denominator. So if I divide 15 by 5, I notice that 15 is divisible by 5 evenly. So my common denominator is going to be a 15. And then, of course, I'll carry it over here, keep my common denominator. 15 goes into 15 once. So if I multiply 15 by 1, I multiply 8 by 1 and get 8. So notice that fraction doesn't change. To get from 5 to 15, I multiply by 3. So that means I multiply the 3 by 3 to get 9. 8 minus 9 is negative 1. So if you notice now, what I said in the very beginning of this video is that these rational answers can be negative. And here's our first instance of that. Okay? So we're going to look at another example. There are 9 here, and we'll get through them as quickly as possible. When we're adding in example 4. Okay, this is example 4. So what we have in example 4 is negative 5 over 8 plus 1 over 5. So the first thing I need to do, just like before, is find my common denominator. My multiples of 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5. Well, I'm going to stop there because my least common multiple is not going to be bigger than what 8 times 5 is. And I know that if I divide 5 into 8, 16, 24, and 32, it does not go evenly. The first number that it goes into evenly is 40. So I'm going to bring down my 40. That's my common denominator. And I'm going to carry it over because that's my common denominator. And if you notice, in the original problem, I've got a negative. So in order to make sure that I don't mess up and forget that negative, I'm going to put it right down here right now. Now I will worry about finding my numerators. Okay? So if I have to multiply 8 by 5 to get to 40, I'm going to multiply 5 by 5 to get to my numerator down there. So 8 times 5 is 40. 5 times 5 is 25. And I already have my negative there. Okay? So I'm not going to put another one there because I already carried down my negative. Going over to the other fraction, I have to multiply 5 by 8 to get to 40. So I'm also going to multiply 1 by 8. And I've got 8 over 40 as my equivalent fraction. Now what I would do is Mrs. DeYoung would tell you, your signs are different. The 8 is positive and the 25 is negative. So the rule when your signs are different is to subtract and keep the sign of the absolute value of the larger. Now, that would be the 25, and that's negative. So our answer is going to be negative. 25 minus 8 is 17. Keeping the sign of the absolute value of the larger means that our answer is negative 17 over 40. Okay, so let's do an additional problem over here. And let's say negative 7 over 3 plus 6 over 15. Okay, first thing to notice is I do not have a common denominator and I need to find one. Multiples of 15. 15 times 1, 15 times 2, 15 times 3, 15 times 4, etc. Okay, so 3. Does 3 go into 15? Yes, it does. It also goes into 30 and it also goes into 45. But remember, we're looking for the lowest one. So our common denominator is going to be 15. And I'm going to write it down here just like I was before. And I'm going to carry it over just like I did before. What I'm going to notice is that that first fraction is a negative. So now all I have to do is adjust each numerator accordingly. Okay? In order to get from 3 to 15, I multiply by 5. So that means that I multiply the numerator by 5. 7 times 5 is 35, and I already had my negative there. Okay? And 15, in order to get from 15 to 15, I multiply by 1, so I multiply 6 by 1. And notice again, that's equivalent to what I started with because my denominator was already a 15. So my signs are different, so I'll subtract 35 minus 6, which is 29, but since 35 is negative, my answer will be negative, and that's my answer. Negative 29 over 15, and leave it like that. Okay, moving on. Example 5. We're subtracting now. We've got a negative 2/3 minus 1 over 9. So first thing, my denominator is not common. Find that. So you probably could make notes here, some pretty viable notes. The first step, find the common denominator. Okay, so that's the first step. And this is the most difficult type of problem, and it would help if I could spell. This is the most difficult type of problem where we've got negatives, and not only negatives, but we are subtracting the negatives. So the first step, find a common denominator. So I'm going to take the multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27, and I don't need to go any bigger than that because my 9 and my 3 are already in my denominator, and 9 times 3 is 27. So what I'm going to do is see which one of these lowest number is divisible by 3. Well, 3 goes into all of them, but we'll pick the lowest one, which is a 9. So finding my common denominator, I know it's a 9, and I'm going to put it there. The next thing I notice is that I've got this negative here, so I'm going to carry that down. All right, so let's make that, say, step number 2. Carry down signs. Okay, I have my minus in between, and I carried down my negative. So I've got a common denominator, and I carried down my signs. So the third thing that I'm going to do is find new numerators, okay? That's the next step, and I'm going to do that right now. In order to get from 3 to 9, I multiply by 3, so I will multiply 2 by 3 to get 6. And remember, my negative is already there. In order to get from 9 to 9, I multiply by 1. So 1 times 1 is 1. Now, the last thing I'm going to do is find the answer. Okay, I have a negative 6. I'm going to carry over my denominator. Okay, sorry about that. That's the easy part. I've got a negative on my 6, and I've got a negative on my 1. Mrs. DeYoung would tell you both the signs are the same. You add and keep the sign. So 6 plus 1 is 7, and since both of them are negative, my answer is negative 7 over 9. Okay? Now let's do an additional problem underneath that. Let's start with, okay, let's look at, I'll have to make one up. Negative, let's say negative 3/8 minus 5 over 16. Okay, so we're going to follow our rules. First thing, find a common denominator. So let's find our common denominator, the multiples of 16. 16 times 1, 16 times 2. That's all we need. Because 16, we know if we look at 8, 8 goes into both 16 and 32. So you could keep going, but the numbers would get large. So we're going to see if 8 goes into one of the first couple that we find, and we know that 8 goes into 16. So my common denominator is going to be a 16. I'm going to bring that down, and step 2 says I'm going to carry down my signs. So the first one is negative, and in between I've got a minus. So that was step 2. Now step 3 tells me to find the new numerator. Well, to get from 8 to 16, I multiply by 2. So I multiply 3 by 2, and I get a 6. To get from 16 to 16, I'm just multiplying by a 1, and 5 times 1 is 5. Now what I have to do is find my answer. That's my next step. So I'm going to find my answer, and I add. I'm going to carry over my common denominator. Because both of my numbers up in my numerator are negative, I'm going to add and keep the sign. So 6 plus 5 is 11, and they are both negative. So that is my answer. Okay? Moving along, we've got the next example, example 7. So this is what I'm going to tell you that we're going to do for, because example 6 was kind of like my additional example, so we're not going to do another one like that. We're going to move on to number 7. And the same thing will apply to number 8. What I want you to do is I want you to change these mixed numbers into improper fractions, because that'll make it easier to follow the rules that we've already set. So example 7 is 1 5/6 plus 4 4/9. Okay, so the first thing we're going to do here is change to an improper fraction. 1 times 6 is 6 plus 5 is 11 over 6. That's my equivalent improper fraction. Do the same thing with the other one. 4 times 9 is 36, plus 4 is 40. 9 times 4 is 36, plus 4 is 40 over 9. Now I can go back and follow the rules that I was already following. Find my common denominator. Okay? So I'm going to find my common denominator by doing the multiples of 9. 9 times 1, 9 times 2, 9 times 3, 9 times 4, etc. Well, I'm going to start by dividing 9 by 6. It doesn't go. Divide 18 by 6, and it does. It doesn't go into 27. It also does go into 36, but we're going to use the smallest one of those numbers. So my common denominator will be an 18. Okay, and then I'm going to follow the rules that I was following previously. I get from 6 to 18 by multiplying by 3. So that means I multiply 11 by 3 to get a 33. To get from 9 to 18, I multiply by 2. So I multiply 40 by 2, and I'll get 80. Now I carry over my common denominator, and then the last thing that I would do to find my answer is to add the numerators together. So 80 and 33 is 113. Okay, and that would be my answer because that is not reducible. Again, just do your best with reducing your fractions. If they're even, you can just start cutting them in half, okay? So the answer to that one would be 113 over 18. And they, of course, leave the answer in the book as a mixed fraction. Unless it tells you to do the mixed fraction, leave it as an improper. And you know from an improper how to find a mixed because we had to go from mixed to improper. So just go backwards from that, okay? And then example 8 is exactly the same thing. 5 1/4 minus 2 3/8. Change to impropers. 5 times 4 is 20 plus 1 is 21 over 4. Minus 2 times 8 is 16 plus 3 is 19 over 8. Now, common denominator. Okay, that's the first step. Multiples of 8. 8 times 1, 8 times 2, 8 times 3, etc. Well, if we look, 4 divides into 8 evenly. So my common denominator is 8. Of course, it also goes into 16 and it also goes into 24, but we pick the smallest one and we bring it down. And we can carry it across. So next step, 4 is multiplied by 2 to get to 8. So we multiply 21 by 2 to get to 42. And 8, to get from 8 to 8, we multiply by 1. So 19 times 1 is 19. Then the last thing we're going to do is subtract in the numerator to get 42 minus 19 is 23. Now, if the book does tell you that to put your answer in a mixed fraction, the way that we're going to do that is we're going to divide 8 into 23. And we know 8 times 3 is 24, so that's too high. So 8 times 2 is 16. So what we end up with is 23 minus 16 is 7. So my answer to 23 over 8 is going to be 2 7/8. It's this 2. The remainder is the numerator over 8. Okay? So that's it for the lesson. What your homework is going to be 2 to 30 every other even, and that's only 8 problems. Show me all of your work and how you find your common denominators, just like we did in this video, and I will be happy. If not, I will not grade that problem because I will assume that you did it on your calculator, okay? So show me your common denominators, how you find them, 2 to 30, every other even, due tomorrow night by midnight. Have a good day.